Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 24th. Looking at significant wave heights for the North Pacific Ocean, we don't see a whole lot going on. Looks like a little bit of wind maybe in the Gulf of Alaska, probably associated with some sort of low pressure there. Maybe another weak low off Japan, but none of these are producing seas of any interest and just really indicative of a very weak both upper and lower level atmospheric pattern that is in control. Let's get into the details. As usual, we'll take a look first at upper level winds. These jet stream level, 250 millibars. These winds help support the formation of gales, and when those gales do form, help direct their track. We're looking for a trough that is a dip in the jet, just like that there. But that's not much of a dip and not supported by a whole lot of wind. What is that, 120, maybe 130 knot winds? Anyway, that helps set up a little bit of a counterclockwise flow aloft and also down at the surface, and that's the hallmark of low pressure. And of course, low pressure generates wind. Winds generate waves, or seas actually, and seas as they radiate away from the fetch area produces swell, and when that swell hits your beach, eventually it makes surf. Anyway, so a little bit of a trough right near the dateline type region. Otherwise, the jets, it's not horrible. Running down pretty far south, around 37 north, and cohesive the whole way across for the most part, across the Pacific, though it sort of looks like there's some sort of a split probably going on right there, and that would dampen storm or gale development over here and actually support high pressure development. See this ridge right here? That would make clockwise circulation down at the surface, and that's the hallmark of high pressure. But that's also what generates wind swell for California, so maybe not so bad if nothing else is going on. Wind swell is okay. Hawaii, upper level low, almost right over top of it. Anyway, let's just sort of roll this out, see what's going on. We see no big change. Trough continuing in the Gulf, but just not a whole lot of wind energy supporting it. The ridge builds to the north here come Tuesday night, suggesting more high pressure. We're looking for kind of anything. There's a pinch trough, but just not really clearly defined, nothing. So there we go. We get into Fridays. Again, sort of a trough trying to form, but very pinched. Needs to be a little bit broader to help some circulation. See, look at that. It just pinches right off come Saturday. Big ridge over the west. Ridge over the East Pacific, nothing really clearly. Gosh, look how big that ridge is. Now, if this could dig down and like carve out there, but it doesn't. Look at how pinched off that trough is. Just does nothing. And 180 hours out, and what do we end up with? Pretty much a cutoff upper level low northwest of Hawaii. And then the whole jet also noticed it moves way to the north. So nothing clearly in the upper level picture suggesting significant swell or storm development. All right, let's go take a look down at the surface. And here you are, surface level pressure, surface level winds. Remember that trough was right about here, and there you go. There's low pressure associated with that trough, but very weak. What is that, like 1,000 millibars, basically, which is almost no low pressure system at all. Remember, there's a ridge over here. As expected, high pressure, little tiny area, 20 knot winds off North California, generating wind swell in the waist to maybe chest high if you're lucky at exposed breaks, and then some other kind of weak low. Even this is 1,004 millibar low, so nothing really going on with any of these. We'll just roll this out. We're into Tuesday. The one low moves up into the Gulf, still very weak. The Japan low moves towards the dateline, doing nothing. Just no energy to really support any development of any kind. Little tiny lows, supposedly. The model's been teasing about something out here come Friday. Notice high pressure, 1030, what is that? 1036 millibar. High building over the northern dateline region. And there it continues building. Now look at this, though. Maybe some wind swell, a little bit of low here. Maybe wind swell, maybe, just maybe. We're reaching for Hawaii. And then comes Saturday night, okay, so a little bit of a gradient off California, maybe some wind swell for next weekend. Again, wind swell maybe for Hawaii. Where are we? We're at 162 hours out. A little bit of a low trying to organize here. We'll pull the control out of the way. A little bit of a low, cut-off low, trying to form south of that high-pressure system right in there. And let's just see if it does anything. Not really. No, most of the fetch ends up being aimed to the to the southwest, doing not a whole lot for Hawaii. So just not a whole lot going on. Weak jet stream flow, probably a symptom of La Nina, typically, or lack of MJO. So the MJO, the Madden-Julian oscillation, when in the active phase, imparts energy to the jet. The jet is looking exceedingly weak. You don't get troughs unless you have good energy in the jet. We don't have that. And so if you don't have a trough, you don't have storms or gales, and then you don't have surf, and so you end up in kind of this summer pattern. Now, it's not really unusual to have kind of be dead in September kind of thing, and we are. But with La Nina going, the thought is, again, that the summer is going to extend for another month. So really, it's like we're in, let's say, late August atmospherically. And so I wouldn't expect a whole lot going on swell-wise till maybe we get into middle to late October. But that's just a rough guess. All right, let's go take a look at the wave models. And here we go. Significant wave heights, North Pacific Ocean. Based on all the data we've seen so far, we expect this to be a complete non-event. But let's just roll through it, see if anything pops up. Wind swell dying off of California come Wednesday. Just go into a dead mode. Nothing relative to Hawaii. Low pressure. Remember that little low we saw up here come Friday. Not expected to do anything, and it doesn't. And then wind swell. Remember, high pressure generating winds here. Low cutoff low trying to develop underneath Hawaii here. What is that? That's like 10 or 12 foot seas. Probably not doing a whole lot. And then you see there we go, 18 foot seas. Now it's aimed a little bit more west of Hawaii. Hawaii's over here, and then 20-foot seas. Here, we'll pull the controls out of the way. You see 20-foot seas, but they're all pushing this way. Doubtful anything's, going to reach Hawaii, and that was 180 hours out. Now, something up here as well. Let's go back and do a quick look. And when you're at 180 hours out, I don't believe any of this, and the models just really don't have much of a handle on things. More than about 4 or 5 days out. A week, it's good to look, good to tease yourself. Don't buy any of it. But given what we've seen here, there's nothing to buy. So, North Pacific, pretty quiet. So just for fun, let's go take a look at the South Pacific. There's been nothing going on there. There is no swell of any interest coming from the Southern Hemi. There hasn't been 30-foot seas in weeks down there. We're showing you this just because we like to drive people nuts. So, and again, remember what we said about the model going a week out. Okay, so then there's this, we're by Wednesday, we're only 66 hours out, some kind of low pressure system building under New Zealand, seas to 39 feet. Come Wednesday midday, that's only 3 days out. Maybe, just maybe, that could create some Southern Hemi swell. Now, let's be clear, all the prior runs of the models have not shown this. The 12Z run today picked up on this, and it gets even more interesting. Now watch this system here. It starts building again come Friday morning in the Southeast Pacific, pushing almost north with, what is that, 37-foot seas, let's say, and then pushing almost due north in the Southern California swell window. That, and given how far north it goes, let's say to there, what's that, about 35 north or 35 south, that means a much shorter travel distance to California. That means much less decay. And if one is to believe all this, and also notice this system over here relative to Fiji, what is that? Let's just go the whole way back. Look at that. What is that? 44-foot seas, is that barely in the Fiji swell window, and building, pushing to the north. So then swell from there, maybe filtered swell for Hawaii, if you were to believe it, and then we're out 180 hours. But the question is, would you believe any of this? I don't. Not for a second, seeing how there has been nothing going on down there for weeks now, but who knows, every now and then things happen. Let's see what happens. So this is the 12Z run of the model. All the previous models we showed you are our 18Z run. The 18Z run for the Southern Hemi is running right now. It should post in 5 or 10 minutes or so, but just go take a look. You can see for yourself. We'll see whether it's still there or whether it's completely evaporated. So that does give us some hope, at least for something. And then let's do a little bit of a closer inspection for wind swell relative to Hawaii and California. Right now, small wind swell. See 20 knot winds right there? All it takes is 15 knot winds. Whether you're Hawaii, California makes no difference. The laws of physics do not change no matter where you are on the face of the earth. But if you have 15 or 20 knot winds, you can get a little 8-second period wind swell out of that, and that's exactly what's hitting California now. This fetch here, but it's got to be in close proximity, a couple hundred miles. We're too far out here. That's 600 plus miles away from Hawaii. Probably not a whole lot of wind swell being generated for that. We watch this. Now notice the fetch builds. Oops, we went a little too far. Relative to California, Monday, the fetch starts building to, what's that, 25, almost 30 knots. Bigger wind swell for California, still nothing for Hawaii. And then into Tuesday, then that fetch starts fading, and the wind swell will fade with it. Still nothing relative to Hawaii. Then you get into the middle to the latter part of the week. Notice low pressure getting close, so that cuts out any high pressure. That, of course, cuts out any wind, which cuts out any wind swell. And then remember we saw that little cutoff low relative to Hawaii. There's your 20 knot fetch and up to 35 knots. It's actually aimed to the south. Maybe some little swell for Hawaii with some luck. But we're 150 hours out again. Okay, and then we're moving into Sunday next week. Wind swell again. The gradient, California gradient, high pressure in the eastern Gulf of Alaska, heat low pressure inland, tightens up the isobars, generates wind, north winds, and that makes for like a wind machine relative to California. And there we go, we're into Sunday, 20 knot winds again, maybe wind swell. Also notice over here relative to Hawaii, there's your 30 knot fetch, but aimed pretty much away from the islands. And let's just get ourselves 180 hours out. Then you get 35, almost 40 knot fetch, but all aimed away from Hawaii. Wind swell again for California. Wind swell winds in the Gulf, probably making wind swell for the Pacific Northwest as well. All right, let's go take a look long term. Long-term outlook, let's take a look and see what's going on with the Baden-Julian Oscillation, like we talked about before, and ENSO, the El Niño Southern Oscillation. Again, the MJO is a periodic cycle that runs 4 weeks on, 4 weeks off. That is 4 weeks active, 4 weeks inactive. And El Niño Southern Oscillation, that is a far longer arc, pretty much 5 to 7 year periodicity. El Niño coming about every 5 to 7 years. La Niña after that, and then neutral in between. As usual, we examine the winds on the equator. This is the main area, East Pacific here, West Pacific here, the equator, New Guinea here. Winds, this is from the TAO buoy array, buoys strung across the equator, the whole way across the Pacific, used for monitoring El Niño, and indirectly you can use it to monitor whether you're in the active or inactive phase of the MJO. We see strong east winds across the entire equatorial Pacific. Anomalies, differences from normal for this time of year. Yeah, easterly anomalies in pockets, sort of a mixed bag over here in the East Pacific, but in the West Pacific, east anomalies for sure. This is the area, the Kelvin wave generation area, from 170 west to about 135 east, 5 degrees north or south of the equator. This is where we look to see the effects, if any, of the active phase of the MJO. If the MJO is active, that of course then feeds the jet stream, feeds storm production in winter months in the Gulf of Alaska, and the indicator of that would be west wind anomalies. But we see the winds, these little arrows here, pointing from the east to the west, meaning that's the predominant way the winds are blowing, stronger than normal from the east. That's an indicator of the inactive phase of the MJO, at least, if not La Niña. And these are actually the least strong the east anomalies have been this week. They've been far stronger for a good portion of this week. Clearly, if not a sign of the inactive phase of the MJO, for sure a sign of La Niña. We'll get into that in a minute. Let's take a look at the wind forecast. Okay, so this is the whole planet on one chart. The Kelvin wave generation area, right in here. Date lines roughly running right down there. And this is the far West Pacific. Blues is zonal wind anomalies at 850 millibars, so that's up about 4,000 feet. Good proxy for what's going on at the surface, and certainly a good way to get a sense of what's going on in the atmosphere. All right, so purples and blues are easterly anomalies. We're in August. Basically, when you see purples, those are strong, nuking, east anomalies. We had a little bit of break, maybe the first week of September, and then a very strong, we'll call it an easterly wind burst, the exact opposite of what we'd want to see. Here's today's date. We just are starting to move into yet another easterly wind burst in the heart of the Kelvin wave generation area. So those little arrows that we saw in the previous chart, if you keep following that day by day, you'll see the expectation is they're going to get stronger, not weaker. All this is clearly signs of at least the inactive phase of the MJO. More likely, it's signs of La Nina. So then we start looking for signs of the Madden-Julian oscillation, the active phase of the MJO. And you see there's literally nothing on this chart. This is outgoing long-wave radiation. If there are more clouds, you'd see these blues. Those are negative anomalies, meaning clouds absorbing sunlight reflecting off the ocean surface. That would be the active phase of the MJO. We see no sign of that. We don't see any sign of the inactive phase either, though. More sunlight reflectivity. So that means sort of the MJO is dead. Very interesting. This per the statistical model. And then we come down and take a look at the GEFS model, and it basically is saying the same thing. Maybe a weak tendency for the inactive phase of the MJO to show up. 2 weeks out. This is a 2-week model run, but basically no sign of the MJO. Then we look at phase diagrams. Again, another way to sort of get what's going on with the MJO. So assume you're looking down on the North Pole. Let's assume the circle is the North Pole, but it's really not. The active phase of the MJO moves from the Indian Ocean, west-east, from Indian Ocean over the maritime continent, say Bali, over the dateline West Pacific, under the United States, on the equator, cross the Atlantic, on top of Africa, back to the Indian Ocean. Big loop, round and round. The heavy dot right there is where the active phase of the MJO is, in the West Pacific. But if it's inside this circle, it means it's very weak. And the further inside the circle, the weaker it is. The further outside the circle, the stronger. So basically, this suggests that the MJO, the active phase, is all but dead. Maybe it'll make a weak showing in the West Pacific 4 days out for a couple of days and then crash again. That per the ECMF model. The GEFS model basically says the same thing, maybe a little bit more of a foray into the Pacific 2 weeks out, but hard to believe. And then the upper level forecast, jet stream level, and what you normally would see this yellow, that's an area not supportive of precipitation. You could sort of say roughly it's the inactive phase, the MJO, but this is so weak and so just nothing associated with it. We couldn't even call it that. The other thing you notice is there's just really no pattern here. No inactive phase, no active phase, no regularity to this, just a completely weak and gutless pattern. So what is going on with the MJO? This chart describes that. So this is January 2017. This shows you the strength of the active phase of the MJO. And last winter, we had a pretty good MJO pattern that was helping support precipitation. But then notice as we got into spring, things really started getting weak. And here we are, basically this entire summer. And you just sort of scan up the chart here and here and here. We're going back to 2011. And just you can see how completely weak and gutless the MJO is right now. It's completely suppressed. So what would suppress the MJO? The most likely culprit is La Nina. And we think that is what is going on, and we'll get into that now in a second. So let's take a look in the ocean, because La Nina does some very specific things, both at depth and at the surface in the ocean. And you'll see these changes in the ocean before you'll see them like in the jet stream, even though we think we were seeing some in the jet stream. But it becomes real pronounced in the ocean first, and then the atmosphere follows. And then as the atmosphere becomes more tightly coupled with what's going on in the ocean, it sort of takes like 2 or 3 months for the atmosphere to catch up. But once it does, and once that ship turns, then it digs in, and then we'll see the effects of that on land. Okay, so right now we look at temperature distribution. West Pacific here, East Pacific here. We're looking down at depth in the ocean, down 500 meters. Okay, these are the anchor lines on the TAO buoy array going across the Pacific. The X's are the sensors on those anchor lines. Most of our warm water here, 29 degrees, not even that warm in the West Pacific, just kind of not particularly warm, let's just put it that way. 28-degree isotherm retracted to 170 west. That's out near the dateline. Normally you'd want to see it a lot further to the east. The 24-degree isotherm to about 126, 127 west. And then cooler water, even cooler over towards Ecuador. What this suggests, remember we had strong east winds and anomalous east winds, and it's been doing this for months now. Okay, so all the warm water that was pulled up here off of South America is being pushed to the west, and instead what you get is upwelling of cold water along the South American coast, and then that just follows the South Pacific high pressure system. We'll get into that in a minute. Okay, differences from normal for this time of year. You can see it a little bit more defined here. Here's your dividing line between warmer water, only 1 degree above normal, and just barely that, so it's not even that warm, and cooler water, 3 degrees below normal in the east and starting to upwell to the surface, so 1 degree or so. So clearly there's a dividing line. Warm water here, cool water here. That's a clear sign of La Nina. There's other subsurface data that we'd like to show you, but NOAA's sites are down right now. There must be some sort of maintenance window going on or something. But suffice it to say, all the data, subsurface is telling us the same picture. Cool water in the east, warm water in the west, but not that warm at depth. So let's go take a look at the surface. How's that manifest itself? Well, as one would expect, it's not a pretty picture. Lots of upwelling off of Peru. The blues, here's your scale, negative anomalies, cooler than normal for this time of year, and continuing over the Galapagos, out off to a point, let's see, Hawaii is right there, almost the whole way to Hawaii. This is the classic sort of La Nina signal, if you will. This is the Nina 1.2 region over here. If the trades are nuking, that causes upwelling, right? Okay, east winds cause upwelling. All that cold water at depth just gets sucked right up to the surface, and then you get this big old pool of cooler water, and the trades just blow that right on across the surface. Now, why is cool water bad? Well, because cool water doesn't support evaporation. And if you don't have evaporation, then you can't. It is the evaporation and warm, moist air moving high up into the atmosphere, getting caught by the trades and then pushed over to the West Pacific. That's what feeds the jet stream. But if you have cool water, you have dry air, then you have dry air above that, and then you just don't get that latent heat energy transferred into the atmosphere, and you don't get storm production. All right, what's the trend for the past 7 days? Well, the good news is it's not getting any colder off of Peru. It's cold, but I don't know that it can get a whole lot colder. You see this sort of mixed bag of cool pockets, warm pockets. That's good news, too, because this last 7-day trend last week when we did this was all cold over there, and it's been cold for a couple of weeks now. So maybe we've kind of reached at least a pause point, but the general thought is La Nina will pulse again, and you'll start seeing blues in here again at some point. And here's the backed off view. Okay, so you can imagine high pressure. So high pressure circulates counterclockwise, and the general atmospheric circulation here, high pressure in the North Pacific, it circulates clockwise like that. Another high sits over the South Pacific, circulating counterclockwise, and you can just see if it's circulating counterclockwise, stronger than normal, it causes upwelling all along here, and then it just gets caught. Remember, but there's a high here, so the two of them working together cause this big upwelling thing, and if you have cool water at depth here, that all starts leaching or erupting up to the surface, then just gets carried off in here, and that basically shuts down the jet stream or cuts energy off the jet stream, and lo and behold, that's where we are right now. No available energy to feed this jet stream because of cool water, because basically La Nina. So let's put this in perspective. Last year at this time, we had the same sort of thing. Cool water, you see it here. But this was, I mean, we were kind of rejoicing, saying if this is all the La Nina we're going to get, this is great, because this is like a Modoki La Nina. Very small coverage. It's westward displaced off of South America. And yeah, we didn't have great surf, but there were moments of big waves in the North Pacific last winter. Not consistent, not a lot of it. And then we go to this year. There we go. Look at that. Now it's cool water, a lot cooler, more eastward displaced. Wherever the cool water is, the strongest of it, typically north of there, that's where high pressure sets up. That would tend to suggest that this winter would be drier for California, less precipitation. The jet stream would push more up into the Pacific Northwest, which is probably a good thing for there because they were dry last year. California got drenched, so now it's their turn. It would also set up offshores for California. Whatever storm formation would probably happen somewhat. Notice there's no cold water here, so this is the most likely candidate. That'd be good for Hawaii. That'd be good for long-distance, smaller swells for California with offshore, maybe Santa Ana conditions, something like that. But that's just a rough guess. And then, of course, to put that in perspective, 2015, during El Nino, notice the presence of lots of warm water, supporting lots of evaporation, supporting lots of energy transfer up into the jet stream to support storm development north of that region, right in here. So let's take a quick look at sea surface temperatures in the Niño 1.2 region. This is the region, the Galapagos, Peru, that area, compared to normal. And we are 1.5 degrees or 1.43 degrees below normal right now. And you go, that's not much, 1.5 degrees? No, that's huge. That's not a huge La Nina, but it's literally 0.5 degree one way or another makes the difference between El Nino versus La Nina. If you're almost 1.5 degrees off, then you're clearly in La Nina territory. But this is not the official measuring region. This is a noisy region. They monitor it, but it sort of gives you just a hint of what's to come. The Niño 3.4 region, the area from 120 west out to 170 west, 5 degrees north and south of the equator, is the official El Nino monitoring region. Last winter, we had basically 0.5 degree above normal temperatures until into about July, and then we started this long downward slide. We got down to about 0.9 degree. Currently, we're at about 0.5 degree, 0.553 below normal. That is definitely La Nina territory. Let's take a look at what's going on in the atmosphere. We've talked about the MJO. We've talked about what's going on subsurface in the ocean. We've talked about the surface. Now let's talk about the atmosphere above, and let's see how coupled or how much the atmosphere senses what's happening in the ocean. Okay? Southern Oscillation Index, difference in pressure between Tahiti and Darwin, Australia. Positive numbers suggest the inactive phase of the MJO. Long-running positive numbers. This is updated daily, and you can just scan right down here. Most of it's positive. We have a little bit of run and negative there. Currently, 7.37. Not that positive, but certainly positive. All right? Then let's look at the 30-day running average. It's all been positive, but not very positive. If we're at plus 10 or plus 15, that's very positive. Right now, we're at 3.56, not a big deal. Okay, then we look at the 90-day running average. So you can use this to monitor the MJO. Positive numbers, the inactive phase; negative numbers, the active phase, the MJO. And then the 90-day running average, it was 0.74 a month ago. It's up to 4.44. Still not bad. When we get up to plus 10, plus 15, then we're in pretty deep La Nina territory. But this is suggesting a trend towards La Nina. And then finally, we look at the ESPI index, and it's like the Southern Oscillation Index, only it measures a difference in precipitation, actual precipitation in the area north of Darwin. And notice this area. Remember, we talked about here's where the cold water is, right here, right? Okay, so one would expect drier air above there. You can look at the picture here. This is showing you rainfall anomalies, and it's just kind of neutral right there, not showing a whole lot of rainfall, but not into the negative numbers. Actually, it is negative up in here, so probably not a good sign. The ESPI index, negative numbers mean a transition or suggest a turn, means less precipitation, meaning La Nina. And this leads what happens in the atmosphere by about 2 or 3 months, and this guy for a month or more has been saying negative numbers, maybe pretty negative, more negative than this. It was minus 1.9 or even minus 2 at one point. So it's backed off a little bit, but this index is suggesting that we're moving to La Nina. We can graph out the 30-day Southern Oscillation Index, the previous index, just to see where it's trending as well. ESPI for sure is trending towards La Nina. Southern Oscillation Index, here was our big El Nino negative numbers back in 2015, 2016. You can even see the pulses of the MJO. And then we get into 2016 and 2017, and positive, but not horribly positive. Maybe that's a good thing. Certainly, it looks like we're headed for a double dip, a 2-year La Nina, which is not uncommon. If it's 2 mild years of La Nina, that's not too bad. And then finally, the CFS version 2 forecast for the Nino 3.4 region, the main El Nino monitoring region. Sea surface temperatures, that's what this is about. Last year, we were kind of warm in the spring and winter months. But then the temperatures down there, right there on the equator, west of the Galapagos, started going negative. And the forecast is, what are they right now? Minus half a degree, roughly. Well, and that's, where are we? We're in September, late September. So that correlates pretty close, maybe 0.6 of a degrees, and it's 0.55. So that correlates pretty well. But this model says we're going down to minus 1.5 degrees, maybe even 1.6 degrees in January. That is a solid La Nina, and that means, of course, all the things that La Nina means for California. It's a legit La Nina, not some sort of like last year's westward displaced Modoki La Nina. This is the real deal. So that would, again, mean drier conditions for California, less surf, the storms are westward displaced, less number of storm days. The storms that do form would be smaller and weaker and not last as long. So all this sort of adds up to not a great surf forecast for the coming months, the winter of 2017 into early 2018. The snow forecast, not so good for California either. But typically during these La Ninas, Pacific Northwest does pretty well. It just pushes the jet further north. So British Columbia, Washington State, somewhere up there, you know your favorite resorts. If you're chasing snow, factor that into your strategy for the coming winter. And so that does it for this week. No big change, really, long-term outlook than what we've been saying week after week after week. But as we get closer to fall now, we're starting to see confirmation that what we expected was going to happen is happening. Not a great situation, but that's the price you pay for 2 years of El Nino. So it's time to pay the piper. We'll do that. And we won't get too upset about it because we knew it was coming. But the good news is, I think once we get past this winter, then we'll be in a much better place for a couple of, for years after that. And eventually we'll move towards a much better regime. The real long-term outlook, the PDO, the data is kind of inconclusive right now. La Nina is sort of taking a hit out of what was looking like a warm pulse of the PDO. That does not mean that we're still not headed towards a 20-year cycle favorable for storm production in the Pacific. Again, we got to pay the piper for these 2 years, then we'll see where we're at. Otherwise, wind swell looks like all that's happening for the North Pacific, Southern Hemi. Hey, maybe it'll wake up if you believe the models. If not, we'll deal with the wind swell. Figure another couple of weeks, we'll get into the fall pattern. We'll start getting some more surf and make the best of what we can do with it. All right, that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.